Welcome to this eLearn Security video training lesson on network discovery. In this video, we're going to demonstrate the basics of the Wi-Fi reconnaissance process. We will examine a series of tools that can help us in finding vulnerable networks in the area and provide valuable information we need to proceed with the next steps of a wireless penetration test. The first tool we're going to try is named Insider Office. Insider is a very simple to use but very powerful tool. It runs on the Windows platform, so we will need a Windows-based operating system in order to use it. For convenience, we have previously installed the tool on our machine. If you haven't done it yet, you can download the tool from the vendor website. Insider is a commercial tool, but from the website we can download a free trial that will work for a few days. So let's start Insider. In the first window of the program, we can choose which Wi-Fi adapter to use as a default scanning device. Since we want to use our external USB dongle, we select it from the listed options. If we now click on the Network tabs, we can see a list of available networks in our area. Insider has been actually developed as a dedicated Wi-Fi network optimization tool. In fact, you will find a lot of information that you may find useful if you plan to deploy a wireless network. For example, the bottom left chart shows channels occupation, highlighting your currently selected network. However, we're most interested in the network security settings used by neighboring Wi-Fi access points. As we can see, Insider provides an easy-to-read network list with a lot of data useful for penetration testing purposes. The first column shows the network SSID. The second column contains a small graph of the network signal strength. The next column shows the network channel, while in the fourth one, we'll find the most interesting single piece of information, the network security configuration. Examining this column, you can easily see that most of the networks in our area use WPA2 personal encryption scheme. The next column shows the BSSID that you know corresponds to the MAC address of the wireless access point. This information is needed for almost every attack you will learn when we will examine the attack tools. The last piece of information you may need is the AP vendor. For example, this could be useful to determine default configuration settings like router administration passwords, IP subnet, or gateway IP addresses. If you are in a very crowded area, you may need to filter this list in order to focus on a particular scenario. Insider provides a set of filters that you can use for this purpose. Here we've set the filter on security settings to display only WPA first version networks. Another option for Windows users is Wireless Net View. It is a very small and simple utility developed by Nearsoft. This is the official web page of the tool, and at the bottom you can find the download link. If you launch Wireless Net View, you will be presented with a very minimal user interface with no fancy graphics at all. The tool provides all the information you need in a nicely tabulated list view. You can also order found networks for each table column. You can also double-click on a single network to open a dialog window displaying network properties. A nice feature of Wireless Net View is the ability to generate reports in a variety of formats. Just select all the networks or a subset of them and click on the Save icon. You can save the information as a human-readable HTML document, but you can also save the data in a parsable format for automation scripts like comma-separated value files. This is an example of the HTML output created by the software from our scan. We will now switch to Kali Linux as we will demonstrate how to use Kismet tool. Kismet is a very powerful tool that can harvest a lot of interesting information about surrounding networks. It needs a monitor interface to work properly, so we will assume you have already connected your wireless card, properly loaded its driver, and put it into monitor mode. In our configuration, the monitor interface is called mon0, as you can see from our output of the iwconfig command. We will now run Kismet, telling the software to start listening on the mon0 interface. Upon execution, Kismet will ask if you want to start the Kismet server. Just click yes. On the next window, just click on Start, as the options were already correctly set on the command line. Finally, click Close Console Window, and you will be presented with the main Kismet interface. Similarly to Insider or Wireless Net View, we can see a list of nearby networks, but you will shortly notice some major differences. First, along with the usual SSID channel and BSSID, Kismet displays various network activity parameters next to each list item. For each network, you can read the number of captured packets and their total size. This is very useful information. For example, when pen testing web networks, the more data frames that are transmitted, the better it is. Also, and this is completely missing from the other two tools we tried before, you can get the number of clients connected to each network. If you click on the network list, you will be able to use your keyboard arrows to navigate it. Moving up and down, you will see additional information about the selected network, like the use cipher suite, the last time the network was seen, and the access point vendor name. The central point of the UI will also change accordingly, displaying the list of clients associated to that particular network, along with some statistics about the traffic they generated. Kismet offers a color code to easily identify networks by their security configuration. WPA and WPA2 networks are assigned the orange color. Red is for web networks, while green stands for the open network, as you can see inspecting our networks list. If you click on a network, you will open a new view showing a real-time graph of the network packets rate. The central part of the window also displays other variable information such as signal level, encryption scheme, and some statistics about the captured frames, grouping by their type. From the top menu, if you click the View Clients, you will be presented with a list of stations which were discovered for the selected network. You can directly click on one of them to get further details, for example, when the client was first and last detected or its signal level. Now that you know the basics of the Kismet UI, let's go back to the main window of the tool. Once you have identified a possible target network, you should lock your wireless adapter to listen only on the target channel. Notice that Kismet is now running in channel hopping mode, as you can read on the bottom right corner of the user interface. To lock the channel on a specific value, navigate to the Kismet top menu, click on Kismet, Configure Channel. In the next window, click on the lock, and in the input field, enter the desired channel number. Lastly, click on Change. The Kismet UI now correctly displays the channel we have selected, as you can see. Locking the channel will give you more accurate information about your target. We will now demonstrate how to determine the SSID of a hidden SSID network. This will be a good occasion to try another reconnaissance tool, AeroDumpNG. It is available for the Linux platform and included in the AirCrackNG suite. For this task, we assume you have configured your test access point to hide its network SSID, as we did in our test environment. Let's first discover AeroDumpNG. The basic syntax of the command only requires you to specify the monitor interface you're going to use to scan the wireless medium. In our case, this is the Mon0 adapter. As Kismet and most other tools you will learn to use, AeroDumpNG also comes with a very simple text-based user interface. In the top section of the output, we read the actual wireless channels, the elapsed time since the scan started, and the current date. By default, AeroDumpNG uses channel hopping, so you will see that it continuously jumps between channels. The central part of the screen displays a list of available networks in the range of your wireless adapter. As usual, the tool reports an interesting amount of information about discovered networks, like the signal power level, the number of received beacons, the wireless channel number, encryption and authentication settings, and finally the SSID name. In the last column, you notice that some values are reported as length 0 between the angle brackets. Those items correspond to cloaked networks, and we will shortly discover how to determine their SSID. Note that for the moment, we set aside two very important columns of this output, data frames and data frames per second, displayed as --s. The two columns will be significant value, especially when we will learn how to crack web network keys. For now, you just need to know that they give a numeric representation of the traffic flowing in a particular network. Coming to the bottom part of the output, you can see the list of detected stations. For each of them, AeroDump determines the BSSID to which they are associated in its MAC address. You may notice that the BSSID column often reports not associated. This is typical of clients that are sending out probe requests and are not really associated to any network. Let's exit the tool by pressing Ctrl-C and refine the syntax a little. Type this new command. The "-c option will lock AeroDump NG on channel number 11, while the "-a will offer out all unassociated clients from the station list. This way we'll get a nicer output. Let's run the command. AeroDump NG offers the ability to interact with it using the keyboard. For example, pressing space when you are focusing AeroDump NG window will pause the output. Pressing it again will resume it. This will come in handy later when we will need to copy and paste some of the values. If you press the tab, you enter the access point selection mode. Using the up and down arrows, you can now scroll the list. Notice that the currently selected AP is highlighted, and so are all the detected clients associated with it. As a style touch, you can also use mark every AP with different colors by selecting them and pressing the M key. Pressing it multiple times will cycle through alternative colors. Another feature of the user interface is the ability to sort detected networks by particular columns. Just press the S key repeatedly and you will change this sorting parameter. As promised, after this brief overview of AeroDump NG, we will now try to decloak a hidden network. AeroDump NG is already open and locked on the correct channel, so we don't need to rerun it. Just leave its window aside so that you can see the moment we get the SSID name. Of course, the first and easiest option we have is to simply wait for the client to associate to the hidden network. As explained in this course, association frames contain the SSID in plain text, and if AeroDump NG captures them, it is able to match the recovered SSID with the previously known BSSID value. But as we could read from the AeroDump interface, there is a client already associated with our cloaked network, conveniently colored in red. Let's see how we can de-authenticate this client and make it to reassociate to the network, and then recover the SSID value from the captured traffic. Open up your favorite text editor and note down the AP BSSID and the client MAC address. Now let's start a new terminal window to launch the attack. We will try the de-authentication attack against the associated client using the Air Replay NG tool from the Aircrack suite. Let's write the command. The A is followed by the access point MAC address, and then the C is followed by the client MAC address. The 0 option of Air Replay NG stands for de-authentication attack mode. We must also specify the BSSID with the A parameter and the client MAC address with the C parameter. We can now run it and take a look at the AeroDump NG output. As we can see, the network SSID value has been correctly determined and it revealed itself as lab network, like we expected. So in this video, we have learned how to use various tools that will help us in the first tasks of your penetration testing process. We also discovered how to bypass simple security mechanisms like a hidden SSID. Thank you for joining us.